All right, so we're going to look at this problem here. It can be a little confusing, I think. I got confused for a while about it, and I think the way they do it in the book is a little confusing too. So the question reads, the diameter of a US dime is 17.9 millimeters, and the diameter of a silver atom is 2.88 angstrom. How many silver atoms could be arranged side by side across the diameter of a dime? All right. So I drew a picture of a dime here. I drew a picture of our dime, and you can envision we're putting silver atoms, these really small things, across the diameter. Remember, a diameter is basically the length across a circle, in this case a dime, and that is our 17.9, okay? And remember, ultimately this is a division problem. This is how many of this little number, 2.88 angstrom, and I will explain what an angstrom is in a second, can fit into this larger thing, this diameter of a dime, right? So right here, we are dividing our small number into 17.9 millimeters. But we can't divide millimeters by angstrom. We need to convert angstrom to millimeters first, and then we can divide our like units and find out our answer, right? So remember, an angstrom is just it's a unit of length. It's a type of meter. It's just a very small, it's equal to 1 times 10 to the negative 10th meters, all right? That's what an angstrom equals. So we can use this conversion factor to get what we need, all right? So let's break this down. So we have 2.88 angstroms of silver. We're going to put that over 1, and we want to change this to millimeters because that is what our diameter of a dime equals, okay? So we know that we can put angstroms in the bottom here. And the reason we're doing that is as we're setting up, and this is called dimensional analysis, we want to get rid of this angstrom, and we are multiplying, so we want to put the next set of units, we want to put angstrom in the bottom, all right? If angstrom was up top, we would not be able to cancel, and that's why I put 2.88 angstrom over the number 1, okay? So 1 angstrom equals 1 times 10 to the negative 10th meters, okay? So we're not there yet because now we need to change meters to millimeters. So we're going to set up our next unit here. Following that same pattern, we know meters will now go into the bottom because meters will cancel with meters. And this is our final calculation. Millimeters will be our last unit here. So before we even do this, all the units are canceled out except for millimeters. So we know the final answer will be in millimeters, okay? So we need to remember how many millimeters are in a meter. So if we just remember, a meter is basically, if you're looking at your base tens, is just, neutral. If you're going up, remember a kilometer is 1 times 10 to the third. If we're going down, however, I always think of a decade. So a decimeter equals 10 years. But just remember we're going down this time, so it's 1 times 10 to the negative 10th. And then, centimeters to the negative 20 millimeters. To the negative, it's 1 times 10 to the negative 1, negative 2, 1 times 10 to the negative 3. So since it's to the negative 3, that's 1,000, right? We know that from a smaller unit to a larger unit, 1,000 millimeters, or you could write it 1 times 10 to the negative 3. That is 1 times 10 to the third, but we're going with 1,000 millimeters over 1 meter. Okay, so this is our final calculation here, and I'm even getting a little confused as I'm going through it. So you always have to kind of double check and make sure that the answer makes sense. Although millimeters is, 1 times 10 to the negative 3, because you're getting smaller and smaller, just remember you're going from smaller units to larger units. And when you're doing that, the number is going to be larger, right? 1,000 millimeters equals 1 meter, all right? So now we can do our calculation here. And our calculation is I have my calculator here, 2.88 times 1 times 10 to the negative 10th times 1,000. So 2.88, you always double check, times 1 times 10 to the negative 10th times 1,000 millimeters over 1. You don't need to put the over 1 there. All right, so the answer we get here is 2.88 times 10 to the negative 7th. And you can even see, it's 2.88 because we're just multiplying by units of 10. We're not introducing any new numbers here. But you can even look at this negative 10, which is an angstrom, and look at this 3 for a millimeter. Negative 10 and a positive 3 is a negative 7. So that makes sense, all right? And this is a very small number. So this answer is our diameter of a silver atom. So remember, to our original problem here, we can now divide 17.9, and this unit, remember, is millimeters because that was the last unit in our conversion up here. So 7.9 millimeters, which remember is the diameter of our dime, divided by 2.88 times 10 to the negative 7th. So we're seeing how many silver atoms fit into this dime. So 17.9 divided by 2.88 times 10 to the negative 7th. So the answer we get, I'll write it down in longhand, 6215277.78. And we can change that depending on how many significant figures we are looking for. The question, the least amount of significant figures is 3. So we're going to do 6.23, 3 significant figures, times 10. And we can check our decimal places here since we're putting it here. That's 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th. Silver atoms. Okay, 6.23 times 10 to the 7th. If we check this with our textbook, we have 6.22 times 10 to the 7th atoms. So there you have it. I think this is just an easier way to look at this. I know it looks kind of confusing just because my notes are a little messy, but we really just broke it down. We double checked our work. We even caught some mistakes that we almost put into this, and ultimately we arrived at the final answer. So hopefully that makes sense.